Now, if you're building a 650, or any low wing for that sake, what has changed in the last year? The header tanks used to have the pumps from the bottom up. The new modern header tanks have the pumps from the top down. It's a different brand of pump, and that's how all of the 2023 and on tanks are. Now, how do you install a fuel system using the new lightweight, very compact, top-down pump installation header tank in a low-wing aircraft? Well, looking at this picture, we see that we're out by the wing of a 650 Zenith. There's an inspection panel, and there's a drain valve. There's also a finger screener in the tank, and we put a fitting in that, and then we put an inline fuel filter, and we drill the holes and the grommets through the ribs until we get into the airplane. This way we can change the filters out in the inspection openings rather than having to do it in the airplane. It is, however, optional to just run a hose from the finger screener into the airplane in front of the spar and have the inline filter at that location. Now, the location here out in the wing where there's limited space, a 5/16 barbed all-metal inline universal fuel filter was used. These are available at all auto parts stores. Some of them are now plastic, but try to opt for a all-metal 5/16 in and out barbed universal fuel filter for gravity setups like these. Now, let's take a look at the next picture and see where this leads us. As you can see, the left side of the picture is showing the finger screen with the single bar brass fitting screwed into it for a 5/16 fuel hose or 8mm. We're using the spring clamps that come with the filter kit in order to make replacement of the filter easy in the future. We're not using the small pieces of fuel hose that come with the filter because it's for low pressure and it's inferior quality to cutting small similar sections out of fuel injection hose, which is what we do when we do an installation here. So we come out of the wing, we have 5/16 200 psi fuel injection hose that we lubricate with O-ring grease, and we use the spring clamps. We make sure that our filter is oriented according to the filter's instructions or arrow on the filter or the markings in, out, so that the filter flows in the correct direction. Then we used a similar system with a 5/16 fuel injection hose and plastic grommets, and we go through the ribs that are the remaining ribs, and we go into the airplane. Some airplanes need an additional inspection holes, more of a permanent one that can be riveted shut in order to clear and get through the ribs that are in this area and then into the aircraft. And we want the feed line from the tank to constantly go downhill a little bit. Even though the airplane has anhedral, we would like to see the fuel line go downhill a little bit at each rib as it enters the airplane. As you can see, contrary to the original drawings where the fuel lines go uphill to the top of the console, we're striving to keep going downhill, 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 And even as we break through the sidewall of the airplane, we're also keep going downhill, and eventually we're going to end up in the center section where we have the small header tank and the fuel pumps located. So how exactly do we get from the tanks to the header tank, and how do we install the header tank in the airplane? Well, it's not the easiest installation, but we've determined that a header tank, an existing header tank, can be machined at Viking to remove the bottom half of the tank, a 1/16 of an inch on each side. That gives a little step in the tank where it can then be lowered between the channel sides that are in the center floor of the aircraft. Also, if the tank is lowered halfway, so halfway is below the airplane behind the radiator and half is sticking up inside, there's enough clearance for the rudder cables to run above the header tank when everything is finished. You still have to carefully tie wrap hoses and fuel, power connectors, and so forth out of the way, but this is the nicest and the most universal installation. Now, once the fuel line enters the side of the airplane and goes into the airplane, we're not saying that it's super easy to route things, but by careful installation, it's quite possible and safe. We have to take into consideration, right, we see here, control sticks, pivot points, wires, and so forth and so on. We also have to be very careful that we locate the fuel cell, the mini header tank, at the right location fore and aft. We want to clear the floorboard doubler that's in the airplane, and we also want to clear the wing spar that's right behind that. So it's a very small window that can be made available for the cutout to drop the fuel tank halfway down. So here we can see the header tank mounted. We cut a hole in the floor, the width of the header tank after machining off about a 1/16 on each side. I think like maybe 50 thousandths. Then we cut a hole in the floor using a uni-bit for each corner, carefully not to interfere with the heel kickboard that also is structural in the airplane. And of course also the crossover tube for the controls, if you have dual controls, so forth and so on. Dual control is going to make more of a challenge. You have to physically route the wires for the push-to-talk switches differently, and just all around. Like there are some bolts there that can be turned around that hold the actual hem joints where it can swing back and forth, and so a lot of precautions, very simple and easy, but the precautions are very important on that setup. So you mount the tank, you cut a hole in the floor, mount the tank, like it'll drop down halfway towards the weld, and then you route one line from each tank through a inline filter and then right to the tank fittings for drainage into the tank, and then you just leave like one from one side and one from the other side, and don't install any kind of valves because it'll keep the tank from being able to burble or burp air from whichever tank you are using into the tank that you're not using. Okay, so we're jumping into a picture where we can see the new style header tank. As you can see, there are no pumps hanging down. It's a very low profile installation. If you do have to remove some of the channel in the floor, it's pretty easy to do. Just cut out what you need, drop the tank in, and then just on the inside or next to the tank, just put some L angles and rivet it to the floor to reintroduce the lost rigidity by cutting the hole. And you can see that here. You see the tank sticking down. All the pumps and the fittings and so forth and so on are up in the top, and filters are in the wing roots, and fresh fuel is draining into the center header tank. Of course, the most important thing with this system is that the left and the right main fuel tank should drain into this header tank constantly, without any valves or anything that would actually cut off the flow by shutting off one side and then not allowing fuel to vent through the opposite side. So because there is no selector valve needed, or nor should there be, and we want to provide fuel to this header tank reliably, we have to allow it to flow from the left wing and the right wing at the same time. Whatever air bubbles are in the system will either travel up to the left wing or travel up to the right wing, because it's open all the time, and that's how the system functions. So no shutoff valves of any sort in this kind of a system. So the importance are, of course, no shutoff valves, and then as we see here, we could screw in a drain. We want a drain on the system, and also configuring the radiator and the header tank is critical on this, because there's very little room between the main spar, the kick panel for the feet, which also is structural across the floor, and the radiator, all that stuff. We've shown some dimensions of that before. It's on our website. So just be careful that the hole is cut in the ideal location, and then beef up the floor with some angle, one on each side. And then other than that, it's very simple. From the header tank, we're going to run pressurized fuel, one from pump 1 and one from pump 2. Right between the rudder pedals, tie down the hoses, and right through the firewall on left and or right through grommets. And then all other fuel connections will be out in the engine compartment, and it'll be just like any other video. We're showing how to install our fuel system with the new system where the pumps are from the top down. Basically, any of the videos showing that, which will be on YouTube and also our website, will allow you to configure the system. We don't want to run the splitter block inside the airplane, because the whole point is to get as much of this outside as possible. We run one line from one pump and one line from the other pump. We bring it through the firewall, and out there we can do all the other stuff, whatever we want in the fuel system. We can have fuel flow transducers, we can have a high pressure filter, we can have the block that gets mounted out there, that has the check valves and return valve and all that kind of stuff. But it all goes outside in the firewall area, and the only fuel that's inside is half of the header tank and one fuel line for the pump 1 and one fuel line for pump 2.